Okay, well, good evening, everyone. I hope you're very excited about this evening, the opening ceremony of the Ceteris Paribus Face challenge. If you want to see everything in the slide, now if you are full screen, maybe you don't see the bottom part of the writings. If you just toggle the chat on, you should be good. So that's just a little trick here. Jules is going to put the Q&A link in the chat. So if you have any question that you don't want to say out loud, of course you will be able to say questions out loud. But if you don't want, you can still post questions in the Q&A link. And yeah, I guess we're good to start. So yeah, today is the launch of the Ceteris Paribus Face challenge, and let's get started with that. So tonight we'll talk about a little bit of context. Then the main part of the presentation will focus on the topic itself and the organization of the competition. Then we'll have a little bit of talk about technicalities and how we created the competition with Jules. And then we will give you a little bit of resource to start with if you don't know anything about the topic. In the meantime, we'll have some presentations from our sponsors. Reactive Reality first, Anova second, and Ubia third. Right, let's get to it, right? What is the context that unites us today? Well, today you all agree that machine learning is pretty much everywhere. The thing is that today we don't have strong regulations and industry standards to actually tell us as practitioners what to check before being, let's say, able to put some model into production. Right now, we're basically all waiting for someone to figure out what should be the standards and what should be the regulations around machine learning. And in the meantime, well, some people get discriminated by machine learning models. The goal of this competition is to actually tackle one, let's say, subtask of this problem. Basically, you're all going to work towards a more responsible AI, and you're going to provide tools to machine learning practitioners to actually check if their model behaves correctly in a particular setting. So most of the time when you have to check for discriminatory behaviors in models, what you would do is you would have a model to evaluate, of course, and you would have to gather two data sets with the difference between these two data sets being what you want to check if your model is biased towards or not. In that case, let's say that you have different aged people in two different data sets. If you feed your model with these two different data sets, you will have two different data sets of results. And basically, if there is a significant difference between the two, that means that your model actually uses such information, uses this bias to actually make its predictions. Well, and a lot of the time, if you've identified these features as being problematic features, you don't want that. The problem with this kind of method is that it requires a lot of data, and that if the data itself, the data used to actually make the evaluation hasn't been sampled correctly, you introduce a bias through the evaluation itself, so it doesn't bring you any useful information. Another way to see this problem is to actually get specific samples and say that you're going to alter these samples slightly on one thing you want to check. For example, here, once again, the age of a person. And if you feed both versions to a machine learning model that you want to evaluate, you're going to get two results. And once again, if the results are different, it means that the model is using this difference between the two images to produce its output. This second way of doing things is a lot more data efficient. You're actually having a very few images, and you're just modifying them slightly with what you want to test against, and you're seeing if the model changes its behavior between the two. And well, it has the benefit to also avoid some statistical biases. So you may understand now why the competition is called Ceteris Paribus. If you've done a little bit of Latin, it means all things being otherwise equal. And that's specifically the goal of this competition. Before jumping to exactly what the competition is all about, I've teased you a little bit, but Jules is going to talk a little bit about what's going to happen. Let's thank the person that we've actually consulted throughout the building of this competition, without whom we wouldn't have been able to produce this content. And in particular, I would like to thank Loïc Murat, without whom we wouldn't have the nice website that he has built for the competition. We wouldn't have had the time with Jules. Thank you a lot also to our reviewing committee, the jury, we will talk about a little bit later in this presentation. Thanks to our partners, the different associations, the student associations from Centrale Lille, Centrale Marseille, and Centrale Supélec, which are actually gathering a lot of the pool of the competitors and which have worked with us on this competition. And of course, our sponsors, without whom we wouldn't be able to actually give you some cash prizes. So I guess we are going to jump to Moritz Kampfelmüller, and my apologies if I don't pronounce that correctly, for the presentation of Reactive Reality, our first sponsor.
Lovely. Let's jump into it. So, good evening, everyone. Thanks for the quick introduction. My name is Moritz Kampfelmüller. You almost got it right, Nicola. Thank you very much. And I am part of the machine learning research team at Reactive Reality. And I'm glad to quickly introduce you to our company and what our goals are. So let's jump right into it. The product we are developing and offering is called Pick2Fit. And its goal is to provide an end-to-end virtual fitting experience for online fashion retail. And it gives the complete experience. So it provides a fun and engaging shopping experience for online shoppers where they can easily create avatars of themselves to later virtually try on clothing. So a little teaser here of what this technology should look like in practice. And we also provide the means for online fashion retailers to digitize their products and enable them for virtual try-on, as well as we provide them with a complete resource to implement our technology into their apps and web shops. So Pick2Fit can be seen as a product family with scalability in mind. So we provide the ends to, or the means to the ends of capturing 3D clothing. So we have a capture kit that retailers can use for digitizing their clothing in 3D. We also provide a complete content service that is used to feed our technology when in practice. So in the apps and web shops with assets, and we can also convert existing assets from web shops into assets able to be used in try-on at scale. And we also provide our SDK that enables online retailers to integrate our technology into their apps and web shops. So this is a complete one-stop solution that brings you from physical assets to the digital representation and virtual try-on in augmented reality, both in 2D. Give me a second. Oh, sorry, that was wrong way. So both in 2D, where we can, again, not show you what I wanted to show. So hopefully now, both in 2D, where we can mix and match different outfits on different people on mobile devices, and also simulating try-on in 3D with complete physics simulation. And of course, all of this, especially with scalability in mind, won't be possible without a lot of efforts into machine learning. So for example, for converting the existing assets of web shops into try-onable garments, we're going to need some additional information such as where does this fit on the body, where can a body fit through, and also segmentation and classification and the such. Also, for producing our assets, we require an accurate segmentation of the garments on the mannequins that they're captured on. From a research perspective, probably most exciting are our efforts in the direction of generating 3D geometries from only single images. So we're doing this for garments, as you can see in this example of this dress up here, as well as for human avatars. So we can also, or we also conduct a lot of research in this area to create 3D avatars ready for clothing fitting just from single selfies from a camera roll. Just to quickly end this on a note about our company, we're currently at around 60 people from all over the world. So we encompass 17 different nationalities of people who work in AR and AI. We have our headquarters in Graz in Austria, and also some offices spread around the globe to facilitate global sales in San Francisco, Tokyo, and also Paris. Thus concludes my short presentation of our company. If you're interested more in our work, feel free to reach out at reactivereality.com. You'll find all the information, or you can also find us on LinkedIn. And we're always happy for any interest, or also for applications for internships or full-time positions. Thank you very much.
Well, thank you, Moritz. I think I'll carry on from there. So I am now moving on to what is most likely the most important section of this whole evening presentation, which is the topic and organization section. In this section, we want to tell you all about your goal in this competition and the organizational side of it as well. So let's start by talking in more details about your goal. As we have explained before, our objective is to create a dataset of faces that are completely similar, except for one factor of variation, so that one can use this dataset to perform tests that can be said all things being otherwise equal. This means that we will give you a reference image, and your submission will consist in creating variations of that reference image, such that a given a given attribute changes in a controlled way. For example, from this picture, classified as a dark-skinned woman with a normal nose, we would ask you to create a variation where her skin tone is pale and one where her skin tone is intermediate. Or a variation where her nose is very flat and one where her nose is very pointy. The dataset consisting of all those images will be your submission. This means that the method we ask you to create is some kind of process, right, or algorithm that transforms the reference image according to the specified modification. Now you might want to ask, but which modifications should we perform? No worries, I'm coming to that now. Obviously, there are some attributes or features, shall we say, that are more interesting to our purpose than others. In our previous example, there are two features of interest: skin tone and nose pointiness. So as we have seen, the initial skin tone of the image is already known. It is defined as dark. And we have defined two target values to modify our image: a pale skin tone and an intermediate skin tone. That is because pale, intermediate, and dark are the three possible values that we have defined for the skin tone attribute. We will talk about how we define those possible values in part 3. Nose pointiness is a bit more tricky. Now, I don't know about you, but I have no idea how to quantify someone's nose pointiness. And as it turns out, I designed this competition. So how then can I define which target values you should use to modify the image? Well, what I can say is that there definitely is such a thing as having a very flat nose, and there is such a thing as having a very pointy nose. The image we have here must simply lie somewhere in the middle, but those extreme values, very flat and very pointy, exist nonetheless. Well, the images you need to create are simply the two extremes of this scale, one where the nose is very flat and one where it is very pointy, and do so regardless of the pointiness of the original nose. As you can see, there are two distinct kinds of features of interest. When the attribute is discrete, we call it a categorical feature. And in that case, your target values are the categories which are not present in the original image. On the other hand, when the attribute is continuous and we cannot define its original value, we call it a cursor feature. In that case, your target values are simply the extreme values of the scale of that feature. And of course, as we want to give as many tools as possible to the users of our dataset, we have prepared a number of categorical and cursor features of interest. We will detail those features and their target values further in this presentation. Finally, as you might expect, we ask that you do all this not on one image, but on all the images from a given reference dataset. And that's it. That's what participating in this competition is about. If it sounds like a lot, good thing we have deep learning to do all of that for us. Works in this direction have been done a number of times in the computer vision literature, and they will constitute a good ground from which to start your experiments. A final thing I want to convey to you on this slide is how your work will be evaluated. We have a whole slide to present this to you a little bit further. Actually, we even have several of them. But for now, what you can remember is that your submissions will be evaluated based on three prerequisites. First, we ask that your modified images remain distinctly realistic human faces. Second, that they contain the modification that we have requested. And third, that they remain faithful to the original image, outside, of course, of the scope of the requested modification. And that's it. We are going to come back on all of those little elements a little bit more in detail in the rest of this presentation, but all you need to know is there. So now, what I want to do before getting back to those elements one by one to clear up the misunderstandings is basically go over first the organizational elements of this competition. And to do that, I will give the mic back to Nicolas.
Right, thank you, Jules. So, what do we expect from you as far as submission is concerned? The submission format is quite simple. That's a zip file with some folders in them, in this file. You'll have one folder per reference image. So to remember, you have actually 72 different reference images. So there will be 72 different folders in that zip file. And for each of these reference images, we expect you to perform each of the perturbations, each of the modifications that we expect from you. And let's say that at one point you're not able to perform a certain modification. Well, in that case, you can simply put the reference image in place. A correct submission has all the images in it. So if you can't provide a certain modification, give the original image. If you want all the details about what the submission is, there is actually a submission guide that we've written for you, and there is also a verification script which is coded in Python to actually check whether or not a certain zip file corresponds to a correct submission or not. So you have all of that at this specific URL. As far as dates are concerned, today is the 8th of March. That's the launch of the competition. You have 1 week from now to actually register your team. So the registration of a team is done all at once. So you're not just registering for you and your friend is registering for himself and then you're making a team. You actually register the whole team at once. So yeah, that's the deadline for that is March the 15th. Then everyone is happy. The competition is ongoing until the submission deadline. And that hits on April 5th. So yeah, that's basically in 4 weeks. You have a lot of time for that. You can organize yourself exactly how you want. And yeah, that's basically when you need to submit. 1 day later, well, the following day actually, starting from 8 in the morning, we'll start a first evaluation phase that we're going to talk to you about in a little bit. Following that will be a jury examination phase, which will actually lead to the award ceremony, which is exactly in 5 weeks. on April the 12th. You pretty much have all the dates here. And well, basically, why are you doing that for? Of course, for pride and glory, as we all do, but you're actually going to work for more responsible AI through your methodology. Then, well, it gives you a chance to publish a paper, because we're actually going to publish a paper with the winning submissions of this competition. And well, you will be able to present your solution to everyone, which is always a good thing. And well, if you like money, as I do, there are 2,100 euros that you can actually win between the different leaderboards. Right, isn't that good? Yeah, it is. So what do you need to do to get that? There are a few things. There are 4 things that we expect from you. First one is simple. I've already talked about it. You need to register as a team before March the 15th. That's the first thing you need to do. And actually, let's show you exactly how it's done, so that there's no misunderstanding about that. If you go to that page, which is the page which is on well, the top right corner of all the presentation, you get to this page here, and on that page you can actually have some information where you have everything. You can log in and you can register, and of course that's where you're going to go for that. When you're in the registration page, you can register all the members of the team. You choose a password for the whole team, which will allow you to actually get to the team space and submit your work. You have a few things to check, things that we need you to comply with to join the competition, and then you can register and everything is good. Almost good. You need to verify your email, otherwise you will not be able to log in. Once you've done all of that, simple, 5 minutes, you will be registered to either the youngsters leaderboard or the main leaderboard. If everyone in your team is in the first year of engineering studies in one of the 3 partner schools, which are Centrale Marseille, Centrale Lille, and Centrale Supélec, you will join the youngsters leaderboard. If at least one of the persons in the team is not a first-year student in these schools, you will join the main leaderboard. And as far as prices are concerned, there's 60% of the 2,100 euros going to the main leaderboard and 40% for the youngsters leaderboard. That's the first thing. Second thing is that you need to submit. Okay, the submission has to be done before April 5th. That's basically the deadline. And how to do that? Well, let's show you. It's quite simple. Once you've registered as a team, you can actually log in. If you have verified your email address, just put your email address, the password of your team, you just sign in, everyone is happy, and then you can submit. So yeah, you just have to upload your zip file. We advise you to check it first with the Python script. You check everything and you can submit your work. And well, that's basically all there is to it. So once we've done that, I've told you a little bit about a collaborative review. That's because we're going to actually ask you your input on how qualitative these submissions are. The hard truth is that in computer vision, it's extremely hard, if not impossible, to design metrics which actually quantify what you want to quantify. And in this specific case of actually designing this competition, we've not been able to do that with enough confidence to actually rely fully on automatic metrics. So yeah, we're going to ask you a little bit of time, something around 30 minutes per person, to actually give your input about how successful a certain submission was. And we'll explain to you a bit later exactly how it's going to be done. The final thing we're going to ask you to do, if you actually pass the first phase of evaluation, 6 teams are going to pass that phase, we're going to ask you to present your methodology to get to the Ceteris Paribus modification dataset. And that will be done on April the 11th. So yeah, that's basically all we ask you to do for this competition. The ranking procedure is actually quite simple. If we take all the submissions, at first we have the first evaluation phase, which is the collaborative one I've just told you about, and that is done on April 6th between 8 in the morning and 11 in the evening. From that, we're going to have 3 winning teams from the youngsters leaderboard and 3 others from the main leaderboard. that are going to be sent to the jury for a blind data review, and the jury is actually going to do exactly the same kind of thing that the collaborative evaluation is going to do. This will provide a data mark, a data review. At the same time, the competitor teams are going to present their work to the jury on April 11th. I've just told you about that, and that is going to provide a method review. And from these two marks, we're actually going to be able to design a winner. So just to sum up what people are going to evaluate submissions on, we need the outputs to be realistic. We need the images produced to belong to the same distribution as the original one, basically. We want to check that the target modification has been achieved, and we need to check that it has been performed surgically, which means that we have not changed that much the rest of the image. We will probably also check some things, weight a few things in the metrics to take into account sample difficulty, and Julie is going to talk about that a bit later in this presentation. All right, so I guess it's time for Sabri Skiri from Anova to actually present the company, which is our second sponsor.
So, thank you for the invitation. So, I have a few slides, not a lot, not mind about that, just to introduce a bit Anova and presenting who you are, who we are. So, I'm Sabri, I'm the research director, so I have the pleasure to lead the R&D department. So, my role in the company is to define the topic we need to invest today in order to be ready on the market within 2 or 3 years afterwards, when the market will ask for this knowledge or technology. So what is Anova? Anova is a really special company. So the mission we have is first to explore the most promising IT technology, and especially here around data science and data engineering. Why? For building knowledge and skills. And those skills will be used for the second mission, crafting products. We develop technologies for customer clients to implement those knowledge for bringing them value to them and resolving their challenges. And the third mission is still to reuse those knowledge for serving our customer. And this is all the consulting and advisory mission that we have. For doing that, we're organized into 3 departments. First, an R&D department that I'm leading. The department is working a bit like a research lab. So we do a research program over 2 years. The only difference with academia is the timeline of the research. So as I told you, we have 2-year program research. We do state-of-the-art exploration of what we can do as contribution. We contribute into scientific conferences, journals, or workshops. We even organize workshops by ourselves. So it's a bit like a research lab, but with the objective to have an impact on the market and to create usable knowledge that will be reused by our consultant or by the product. The second department is the advisory, represented here by the customer challenges you see here in the upper bound of the picture. And this is where we have the advisory and consulting mission. And in the middle, if we see recurrent needs in our customer, and if we see technologies in R&D that can be used for that, then we have an opportunity to create products, and that is the product factory or the product incubator that we are developing right now in Anova. So the main field of expertise are artificial intelligence, data architecture. So, data architecture is anything linked to the underlying system to be designed for supporting your artificial intelligence. So that means all the system for data pipelining, data transformation, data storage. This is all the things that you have probably heard about, the data lake house, which is a kind of merge between data warehouse and data lakes, and all the data engineering for supporting all those things. And of course, software engineering, because, well, if you have artificial intelligence, data architecture, the next step is building applications. Within the R&D department, as I told you, we work a bit like a research lab. So far, we have a bit more than 55 scientific publications in international scientific conferences. So for us, publishing is really important because, first of all, it allows to get feedback from our peer into the domain. So we are doing research, but we don't really know if we're going the right direction, if what we are doing is relevant or not. And having some feedback from the reviewer and publishing paper is a really good way to get feedback. Secondly, it's a bit weird for a company, but we realize that for us, publishing paper is actually a marketing argument. When we are in competition with people like Accenture or Deloitte, the fact that we have paper and scientific publication in really niche artificial intelligence or data science or data engineering shows that we have the right expertise. So it could be seen as a marketing argument. Then your next question will be, but Sabri, how can we work together? Well, there are many ways we can work together. First of all, well, by internship. Every year we publish a list of internship topics. So don't hesitate to go on research.uranova.eu. You will see the list of offer in terms of internships. We also organize PhD, so it could be funded directly by Anova or working in collaboration with PhD students at university. It's something that we do as well. And finally, we have the bootcamp, which is a kind of recruitment program for young graduated. So as soon as you have your master, you can still apply to the bootcamp program. It's a kind of training program of 3 months where you will have intensive training supervised by in-house experts. If you have any question, please send me a mail, or you can directly go on job.uranova.eu or send me a mail to career@uranova.eu. Thanks a lot.
Well, thank you, Sabri, for this presentation of Anova. Let's dive into the third part now of this presentation, which is going to be a technical description of this competition. And first, I want to talk about the reference dataset, right? This dataset that you are going to have to modify. So our dataset is a subset of FFHQ, which is a research dataset created by NVIDIA in the scope of their research on face generation. The first thing we did is we removed all of the samples from FFHQ which are not commercially usable. Then, to go further, we needed to define some features. We have defined a few features which sounded important to us, and then from each of those features, we have defined a criteria to discretize those features into target values. Let's talk a bit more about the skin tone feature, because it's usually a very interesting one and also a very delicate one. To split the skin tone into discrete values, we use the Fitzpatrick scale, which is basically a scale that is used to basically describe how a certain skin tone will react to the sunlight. It's a little bit old, but still very relevant in a lot of research nowadays. So we thought it would be a good one to use. And it's also very easy to discretize target values based on this scale, visually speaking. Next, well, the other ones are a little bit less interesting. They're very straightforward, but I would like to talk a bit more in detail about particularities as well. What we call particularities is basically, is there an occlusion factor on the image or not? In other words, is there something that occludes part of the face on the picture or not? So this could be, for example, sunglasses, this could be facial hair, anything like that is going to count as the image having a particularity. Now that we have defined all of these criteria, we can get our different values. So for example, here that would be pale skin tone, intermediate skin tone, and dark skin tone, etc., etc. And what we want in our dataset is actually that all those values are equally distributed. So what we do to that end is that we are actually going to create a dataset that is the combination, actually the dataset will be all the combination of those values. So it will be the product of this, so in total 72 images. So this means that we will have a few samples that have pale skin for all ages, all sexes, etc., etc. And then the same for intermediate skin tones, and then the same for dark skin tones, etc., etc. In short, what we ensure by doing that is that the base dataset that we are using for this competition is as diverse and fair as possible with respect to at least a few features. Then from that, we only need to resize to 512 by 512, and then we need to test for consistency, which is something that I'm going to talk in a bit more detail on the next slide. But basically, it's a step that allows us to verify how trustworthy our classification is. Then we need to determine all the additional labels which you will need to know what modifications need to be done. And we basically compile all of those labels in the naming convention of the images. So we'll come back on this, but basically it means that all the numbers in the name of an image gives you a label that describes this image. All the necessary information on this is in our data documentation.pdf, which is downloaded basically with the dataset. And this is the reference dataset, which will give you for this competition. Okay, wonderful. So now let's talk about this consistency test I was talking about, right? To do this, basically we took a predictor for pale skin tones on the internet, and using this pale skin tone predictor, we tried to get a score for all the samples in our dataset. As we can see here, the pale skin tone samples in our dataset get a pretty high score, which is what we would have expected, and the dark skin tone samples get a pretty low score, but the intermediate skin tones are a little bit more ambiguous. And if we now use a classifier for intermediate skin tone or for dark skin tone, well, we will see that the dark skin tone predictor is pretty good as well. So our pale samples are all the way down. Our intermediate samples are a bit more distributed, but still okay. The dark are up, pretty fine. And we see that the intermediate predictor is, it indeed shows that the intermediate class here is a little bit more difficult. Why do I tell you all this? Well, we said that we would weigh the samples with respect to how difficult they are to modify for you. And this is the first hint that we have to build this. Now we can do the same for age, for example. So find predictors for young age, intermediate age, etc. We see roughly the same thing. The age is a little bit less ambiguous than the skin tone, but still the intermediate class is the hardest to discriminate. It's a bit better, but it's not perfect. The sex, however, is very easy to discriminate across our dataset, so it's pretty clear cut. And finally, the corpulence is by far the most difficult one to discriminate correctly. So the predictor we could find was not really able to significantly show a difference. Those distributions are almost the same. Now, we did a second test after that. If you remember well, we have a whole part, at actually half of our dataset, are samples with particularities. So we asked ourselves, are those particularities making things harder for those predictors? So we did the same results, except without the particularities. So we only used the samples that have no particularity. And well, it's probably a little bit hard to see, right, the difference between those two slides. But what I can tell you is, for example, for the sex one, we can definitely see that the only few samples that were incorrectly classified are now correctly classified. So to some extent, removing the particular samples helps. But in general, and in particular for corpulence, it doesn't change much, right? So the particular samples are sometimes an issue for the predictors, but not always. So it's not as hard to classify comparatively as we may have thought. Okay, so that's basically what I wanted to tell you about the dataset. Now let's talk about the features of interest, those features that you need to modify. So they are very important. And since they are very important, we determined them via a 3-steps process. Our first step was a consulting process. We basically consulted with ethicists, ethnologists, sociologists, and asked them which features should be important. Now, what do I mean by important? Basically, we defined importance as, is it possible for someone to be harmed if they get discriminated against based on that feature? And from that, we got a list. And some elements in that list are pretty obvious. Some elements are a little bit more surprising, perhaps. But basically, this list is the theoretical best we could have done in terms of features of interest for this competition. But theory is not all there is, and that's why we have a step 2, which is technical availability. Now we enter the realm of constraints that we have to obey, unfortunately. And the first constraint is we can't really ask you to modify features of interest of which no example exists in datasets that are online, because that is probably what the models you will use are trained on. So this rules out a lot of them, but we still have a few of them, all the bold ones here. And if we, for example, look at those, in the fair face dataset, you will have age, population, sex, etc. And then in the Celeba dataset, you will have a whole lot of other labels. We had to, of course, rule out some of them because they were too vague, or some of them because clothes, well, they're on mostly the body, but more rarely on the face. Some of them were very underrepresented in the existing dataset. But we still had a lot left. But that's not the end, right? Step 3 is technical feasibility. And in there, we need to rule out the elements that are really poorly represented in the existing datasets. So for example, we would remove from those lists features of interest which, for example, suffer from a huge class imbalance in the existing datasets. And from there, from that, basically, we arrive to our final list of categorical features of interest, right? Remember, categorical features of interest. And then our final list of cursor features of interest. So here they are. You've got everything on that screen. And of course, that means that we had to remove some. For example, this one, because it was too unbalanced a class in Celeba. Or these ones, we had to merge them together to simplify the process. And these ones, we had to approximate those classes into skin tones to make it work. But we really wanted to because it's a very important feature to cover. Now, that being done, you should have a better view on how we designed and chose our features of interest. But we also need to come back on those target values which define which modifications of the image you need to create in the scope of this competition. So let's go over it once more. For the cursor features, all those 6 ones, you will need to create extreme variations. So for example, for the pointy nose one here, even though we don't know the nose pointiness in the original dataset, we can still ask you to modify those in such a way that their nose become flatter. And we can ask you to modify those in such a way that their nose become pointier. That is what you need to do for cursor features. So always a cursor feature has 2 target values, which are the extremes. Then we have all those categorical features. And for each of those categorical features, well, in the reference image, the categorical features value is known. For example, for the skin tone here, it is known to be dark. And therefore, we ask you to create 2 new variations of this image, one where the skin tone is pale and one where it is intermediate. So to summarize, for all cursor features, we ask you to create extreme expressions of that attribute, so by making it minimal or maximal. And for all categorical features, we ask you to create all the expressions that are not present in the original image. For example, if it's a male, create the female version. So that's it. That's the target values. But let's summarize all of this. If I take one image from our dataset, this one, for example, we have knowledge of a few elements about this image, right? All of those labels. And all of those labels are compiled in the name of the image in the dataset. All of this is explained in our data documentation.pdf file. And then from there, all the categorical features to modify can be found by just crossing out what is already there. So it's already pale, it's already intermediate age, etc., etc. And if we take what is left, what you need to create is intermediate skin tone, dark skin tone, etc., etc. As you can see here, there is a bit of an exception, which is baldness, right? The fact of not having hair. Because indeed, we have one feature which is the hair color, and one feature which is the hair shape. So not having hair is kind of a hair shape and a hair color at the same time. Of course, obviously, we don't want you to create two bold versions of an image. So you just need to create it once, and it will count for both the color and the shape. Then this would create you 12 variations of a given image for the categorical features. If you're smart, you may have noticed that actually if the reference image is bold, you will have one more to do. So for the very few samples that are bold by default, you will have 13 variations to create. And then we have the cursor features. Cursor features are those 6 ones, and as I mentioned, for every cursor feature, you need to create the minimum and the maximum of that scale. So this means that for 6 cursor features, you have, once again, 12 variations to create. So to summarize everything, for each reference image, you need to create 24 modified images, and actually 25 if the reference image is bold. Okay, perfect. This should be all you need to know, but I still want to add something about the evaluation procedure. We have told you that we would need your help in evaluating the submissions in the day after the submission deadline. This is probably very easy to explain, so I wanted to give to have a word with you here about what it should look like. Now, this is still very much work in progress, right? So don't be afraid if this is not exactly what you will see on the D-Day, but we will get all that information to you ahead of time, so you should not be surprised. But basically, what you should see on your screen is the reference image corresponding to a certain modification, right? So we will have the information of what was the reference image and what was the intended modification. And then you will see a first submission from a first team and a second submission for a second team, which will, of course, not be your team, right? You won't see your own submissions there. And then all you need to do is to click on the submission that looks the best to you. You will do that for about 30 minutes, and you're good to go. Then this leads us to the award ceremony, right? But the world doesn't end at the award ceremony. So I also wanted to tell you what happens after the award ceremony for this competition. Because as we told you, we want to create a beneficial change. So for us, it only starts here. The first thing we need to do is we need to gather as much information as possible on the winning team submission. Because what we need to do then is to publish all of that information, including the submission itself, such that it becomes usable for the public. Then after that is done, within 2 months, we of course need to send you the money. I'm sure you would like that. And finally, we will try to submit a paper with you to publicize this nice work that you have done, and also to get some feedback from the scientific community. All of this being done, and I'm afraid I have talked for a long time, I am now leaving the stage to Jules Treuil from Hubia, who is our third sponsor, and yeah, I guess Jules can tell you about them.
Okay, I will be very short. The Hubia was created by Central Supelec like 1 year ago, and the aim of the hub is to federate everything of AI in school. So we have students, we have searchers, we have teachers, and we have also startups. And but we work in many laboratories, and there is like 7 laboratories in 3 campuses doing AI on data at Central Supelec. So the aim of the hub, is to federate all the searchers on PhD students. We have 75 searchers in AI and 150 PhD students in AI. So, but before us, everybody was working by lab, and now we made like one structure in order to give opportunities to the searchers to work together and to give them other partnerships opportunities with companies to do like chairs. We have 5 chairs and we are working on new chairs. So we are really happy to support the challenge.
And we are very happy to be supported by you. So thanks again for your sponsorship.
My pleasure.
So yeah, we just wanted to give you some resources in case you've not played with image edition with machine learning. So the datasets that you need to be aware of for this kind of stuff are FFHQ, a very well-known dataset, probably a more well-known one, Celeb, and Fairface. The first one being very large, high quality, high diversity, and well, which doesn't have a lot of labels. Celeb, which has a lot more labels, but is a little bit less diverse and has a poorer representation. And Fairface has some labels and very good diversity and representation. As far as models are concerned, you will probably come across a lot of models like StyleGAN2, for example, which has the very nice benefit of having multiple latent spaces, which allow you to actually edit images in latent space. So you can modify images based on semantically meaningful features. And I guess to edit images, latent space edition is probably the way to go in most cases. So we advise you to take a look at these 2 scientific contributions, which are very good. Of course, you're not forced to use these works to do your submission, but these can be very interesting for you. Let's finish with the links you need to know. The registration link, of course, the dataset link, because you want the data to start doing the task, the competition rules, submission guides, the team page login once you've registered yourself, the slides of this talk if you want to check something out, and if you have any question, of course, we're open to answering them. And well, to finish, all of that can be found again with this very simple URL that you've seen all over the presentation at the top right corner. So yeah, you just need to remember this one and you can get everything from there.